Good evening, everyone. Am I audible to all of you? Can anyone confirm once? Okay, I guess I am. So let's begin. I assume all of you are here. So in the last class, we have discussed the linear differential equations, the Bernoulli differential equations, and the exact differential equations, right? And we also understood the idea of integrating factors in the context of exact differential equations, right? So, any questions, anyone, on the previous class discussion? Okay. So, just a brief recap of the most a few important things that we had discussed in the last class. So, regarding the integrating factors, what we understood is that the integrating factors need not be unique, right? A particular differential equation can have several possible integrating factors. And the integrating factor can be solely a function of x, it can be a function of y, or it can be a function of x and y as well, right? And we discussed this question as well to understand that how we are going to find an integrating factor for a particular differential equation. And I had also mentioned that instead of taking the integrating factor like some fx like we have done, if you take an fy or a function of f of x comma y, then also you will get some other integrating factor as a solution to this, right? Okay. So today we are going to discuss this in a little bit more detail. And for some particular forms of differential equations, there are some formulas or rules that you can use to get to the integrating factors directly. All right. For all differential equations, you need not go through the entire calculation process to get to the integrating factor. So that is our starting point for today. So let me just quickly start by discussing the rules one by one. So first of all, I'll mention all the rules one by one, and then I'll show you some applications of the same. So today's topics is rules for finding the integrating factors. Okay. Number one, there are four rules. So if the differential equation m dx plus n dy is equals to 0 and m and n are homogeneous of the same degree, then the integrating factor can be 1 by mx plus ny, where mx plus ny is not 0. Okay, rule number one. Number two, if the differential equation m dx plus n dy is equals to 0, can be expressed in the form f1 of xy into y dx plus f2 of xy into x dy is equals to 0. Then,
So what is homogeneous of the same degree?
okay, I'll explain. Just hold on a minute. Let me just write down the rules. I'll come to the details of it. Okay, just give me a moment. Then the integrating factor can be written as 1 upon mx minus ny, where mx minus ny is not equals to 0. Number 3, if for the differential equation mdx plus ndy is equals to 0, del m by del y minus del n by del x whole divided by n is just some function of x, then the integrating factor will be e raised to the power integration f x dx. Point number 4, if for the differential equation mdx plus ndy is equals to 0, del n by del x minus del m by del y whole divided by m is just some function of y, then the integrating factor will be e raised to the power integration gy dy. Okay, so all of you please take this down, all four of points, and then we'll come to explaining each of these one by one. Okay, so I hope all of you have noted this down. Now let's come to each of them one by one. So first of all, coming to the idea of homogeneous functions. So is anybody aware on this call that what does a homogeneous function mean? Anyone? Okay, so let's come to that part first. So basically the idea is that, so let's say if I have a bivariate function fxy, okay? So let me take this as a small example. So let's say that let u be a function of x and y. And let me take an example like this: x squared y to the power 5. Okay. Then if you try to calculate this function of lambda x and lambda y, where lambda is a scalar basically. Okay. Some constant number. Can anyone tell me what you're getting if you do this?
Lambda to the power 7 multiplied by fx comma y.
Correct. So basically you are writing this, and from there all the lambdas are coming together and you basically get this. Correct. Now try to focus on this last step. So what did you do? You try to change x and y by the same proportion lambda, correct? And as a result, what happened? The functional value changed by lambda raised to the power 7. Okay. So this 7 is what we call it as the degree of homogeneity. Okay. The idea of a homogeneous function is basically if you increase or change rather x and y in the same proportion like lambda in this case, then by what proportion does the functional value change? Like in this case, if you are changing x and y by the proportion lambda, then the functional value changes by lambda raised to the power 7. So the degree of homogeneity of this function is 7. Okay, got it? Let's take one more example. Let u, which is a function of x comma y, be given by x into y plus y. So now if you try to do function of lambda x and lambda y, what are we getting?
Sir, it cannot be expressed.
Okay, because it is becoming lambda x into lambda y plus lambda y. So one lambda can go out common, but you still have lambda xy plus y. Correct. So this function is not homogeneous of any degree. Okay. So the basic idea of homogeneity is a function f of x comma y is said to be homogeneous of, let's say, some degree r if function of lambda x comma lambda y becomes lambda raised to the power r fxy, where lambda is a non-zero scalar. Okay, is the idea making sense to everyone? What a homogeneous function means?
Sir,
Okay,
R has to be a natural number, R.
no, it can be an what do you call that? Any real number.
No, sir, I am asking small r, that the power.
Yes, yes, yes. It can be any fraction as well. It need not be only natural number. Okay. Like for example, if you have x into root y, for instance, then you'll have lambda raised to the power 3 by 2, right? So the function is homogeneous of degree 3 by 2. Got it?
Yes, sir.
All right. So just simply remember it in this way that if I change the x and y in a same proportion lambda, then by what proportion does the functional value change? Okay, so if it becomes lambda raised to the power r, then that r is the degree of homogeneity. To what extent the functional value changes. Okay, and if you can express any multivariate function in this manner, then that function is a homogeneous function, otherwise not. Okay, so coming back to the first rule that, like I was saying, that if you have a differential equation in this way, m dx plus n dy equals to 0, and m and n are homogeneous of the same degree, then the integrating factor will be 1 by mx plus ny. Okay, got it? Is it making sense now? Any questions, anyone? So that means in order to apply this rule, first of all, you need to confirm whether M and N are homogeneous and homogeneous of the same degree. If these two are satisfied, only then can you use the first property. All right. Coming to the second one, again representing it as mdx plus ndy equals to 0. If you can express it as some function of xy, okay, some product function of xy times y dx plus some other function of x into y into x dy. So if you can express your differential equation in this format, then the integrating factor will be 1 upon mx minus ny. All right. 3 and 4 are quite similar. Like for the differential equation mdx plus ndy equals to 0, if this condition del m by del y minus del n by del x whole divided by n is a function of x, then the integrating factor will be e raised to the power fx, right? Now, if you look at this closely, the numerator is basically the condition for exactness, right? We used to call the differential equation as exact if del m by del y is equals to del n by del x, correct? So you're basically checking if the difference is becoming a function of x or a function of y. Got it? So you, for any differential equation, for finding out the integrating factor, if either one of the four criteria matches, then you can straightforward use these, I would say, direct formulas to get to your integrating factors. All right. You need not go through the entire process of calculating like we had discussed in the previous class. And obviously, if the differential equation does not fit either of the four criterias, then you have to calculate it like we discussed in the previous class. Okay. Is the idea making sense to all of you? Any questions? Okay. Now let's take a question to understand how do we identify. Let's say the question is we want to find the integrating factor. So first of all, for this differential equation, can anyone tell me what is my m and n?
Sir, m is xy cube plus y and n is 2 into xy square plus x plus y power 4.
Correct. Right. Now let's go. Let's for to start with maybe step by step. So for point one, if you want to apply the first rule, you need to check for homogeneity and they have to be homogeneous of the same degree. So can anyone tell me if that criteria is getting matched over here? Are M and N homogeneous?
No, sir.
No, right? So that means we cannot apply the first property. Straightforward. M and N are non-homogeneous of any degree, right? So the first property is discarded. The second property as well will not be applicable, right? Because you cannot express m and y as some product of xy, right? You have xy cube plus y. So no matter in whatever way you take common or something, you will not have some function of x into y, right? And similarly for n as well, that also you cannot express as of some function of x into y. So that means the second property will also not work in this case. All right. The third and fourth are quite similar in their approach. So we need to calculate del m by del y and del n by del x, right? So let's try to work that out. What are you getting if you calculate del m by del y and del n by del x? So what is del m by del y? Can anyone calculate and tell me?
The del m by del y is 3xy square plus 1, and del
Correct.
n by del x is 4xy square plus 1.
4xy square plus 1. The
Plus
2 should
2.
be out. Plus 2, right? Yes. So 2xy square. Yeah. This should be right if you take the 2 common.
Yes, sir.
Correct. So now if you subtract these two, like if you look at point 3 and point 4, numerator में बस order reversed है, right? The first one is del m by del y minus del n by del x, and in the fourth one, it is just the reverse that you are doing in the numerator. So you can take it in any order, maybe del n by del y. The other terms is if you subtract it in this way. So what are we getting if you do this?
Xy square plus 1.
Xy squared plus 1. And if I try to divide it by m, xy squared plus 1 in the numerator divided by xy cube plus y. So the y can be out common, which is just a function of y. Correct? So I can use the fourth property and conclude that the integrating factor will be e raised to the power integration of gy dy, which is e raised to the power integration of 1 by y dy. So what are we getting? Can anyone work this out?
Y. Mod of y.
Mod of y. Correct? Others, is it making sense? Any questions, anyone? Okay. So if this is fine with all of you, so let's move on to the next question.
Sir, if it comes as constant, then which one to apply, like function of x or function of y?
So
If we like
in
we are
that case,
dividing by n
yeah,
and also by m, both we get constant then.
yes. So in that case, either of them will be fine, right? Anyway, integrating factors are not unique. So you can, if you are, you can find out integrating factor as a function of x or a function of y. In that case, it won't be a problem. Correct?
Okay, sir.
Yeah. So find the integrating factor for xy squared dx. So first of all, I'll want you to try and tell me which form fits this differential equation.
Homogeneous.
Homogeneous of
So the
same degree?
first form,
Correct. And what is the degree of homogeneity?
3.
3.
3.
Right. So that means the integrating factor will be 1 upon mx plus ny. Right? So can all of you quickly calculate that and tell me what we are getting?
So x square y square minus y whole into x cube plus y cube. Like we can also like y x
Okay.
cube
Okay.
and y to the
Okay.
power
Got it.
4.
So m is xy square, n is minus of x cube plus y cube. So m and n are homogeneous of degree 3. So that means the integrating factor will be 1 upon mx plus ny. So that is x square y square minus x cube y, sorry, xy square था minus y to the power 4. Right? Okay. Are we getting this answer? Any questions, anyone? Okay, perfect. So let's move on. What about this? Which form does this take? So here your m is Yes, anyone? Which form is this matching?
Sir, it is del n divided by del x minus del m by del y m by del y divided by capital N equal to a function of y.
Okay, so let's check that. So if you're calculating del m by del y, what are we getting? 1 plus y square, right? And del n by del x is 1 by 4 times this is also 1 plus y square. So then what you're doing?
Sir, del m by del y minus like del n by del x minus del m by del y divided by capital M. That is coming as a function of y,
Okay,
I think.
del
No,
n
not
by
y.
del.
Function of x actually.
ठीक
Function
है
of
तो
x.
x
Sorry. Function of x.
function of x. So I can do the opposite. Del m by del y minus del n by del x. If I do, that will be 1 plus y square minus 1 by 4 1 plus y square. So that is 3 by 4 1 plus y square. So if I do 1 by n del m by del y minus del n by del x, that will be 3 by 4 1 plus y square divided by x plus xy square. Right? Yeah, we have this 1
Sir, x by
by
4.
4. So this will become 3 by x, right? Correct? Which is some function of x. So that means your integrating factor will be e raised to the power fx integration fx dx e integration 3 by x dx. So what are we getting?
Mod x whole cube.
Mod x whole cube. Perfect. Okay. Any questions, anyone? Is this understood? Okay, perfect. So if this is fine with all of you, now let's come to the last part of our discussion on exactness. That so we have understood that why we are calculating the integrating factor, right? So that we can finally use that to make the differential equation exact. Now, so once you make that as an exact differential equation, then how do you calculate the solution of a of an exact differential equation? Okay. So the idea is that, let's say that if a differential equation m dx plus n dy is equals to 0 is exact. And what does it mean by exact? That is del n by del y is equals to del n by del x. If that is the case, then the solution can be written as follows. Integration of m dx, and in this integration we will be treating y as constant, plus integration of terms of n not containing x, and that is to be integrated with respect to y is equals to c. So if a differential equation is exact, then you can straight away obtain the solution of the differential equation using this expression. Okay, it's like a direct formula that you can use to find out the solution of the differential equation if it is exact. Okay, so repeating it once more. So you will integrate n with respect to x, treating y as a constant, plus you will integrate only those terms of n that do not contain x, and that should be equals to some c. All right, let's take the first example to understand this. Okay, let's take a look at this first differential equation that I was discussing. Where did it go? Yeah, let's say we are talking about this. Okay, so now let's say the question is that I want to solve this differential equation. Not only do I want to find the integrating factor, but I want to solve this differential equation. Okay, and what was the integrating factor that we got for this? It is simply y, right? So what was the idea of an integrating factor? That if you multiply the integrating factor with the differential equation, then the resultant differential equation is exact. So if you multiply the integrating factor with the differential equation, what are we getting? X y to the power 4 plus y squared dx plus 2 times x y cube plus xy plus y raised to the power 5 dy is equals to 0, right? If you multiply that, so that means in this case, this is your m, new m rather, let's say m dash, and this is your n.
It's 2 into x square y cube, sir.
Yes, correct. X square y cube, correct. So can anyone quickly check if it's exact now, just to cross verify? If you do del m dash by del y, what are we getting? And if you do del n dash by del x, is it matching?
Yes, sir.
Yeah. And what's the expression? Can you tell me?
4xy cube plus 2y.
And that is same for both, right? So this confirms that yes, indeed, you can take this as a integrating factor. Now look at this rule once more. So we have confirmed that once you multiply this integrating factor with the differential equation, the resultant differential equation is an exact differential equation, right? So now if I want to solve this, I will be using this expression. So let me write this down. So I want to integrate my m with respect to x. So my m is x y to the power 4 plus y square. I want to integrate it with respect to x, treating y as constant, right? Correct? Plus, I want to integrate n with respect to y, but I'll take only those terms without x. So if you look at it, the first term, x square y cube, I'll not take because it contains x. Xy also, I'll not take because it contains x. I'll only take the last term, which is y raised to the power 5 is equals to, okay. So this will become x square y to the power 4 divided by 2 plus x y square plus y to the power 6. Okay, sorry. बाहर एक 2 आएगा, right? Because I'm taking 2 times y to the power 5. So this will be y cube by 3 is equals to, okay. All right.
So I have a small doubt here.
Yes.
So the solution which we are finding, we have to find for the original equation question, or else for this integrating factor into differential equations.
No. You. This is the solution for the original differential equation only, right? Typically, when you're multiplying the integrating factor with the differential equation, you're not changing it, right? It's multiplying the integrating factor on both sides, right? Just that for our case, the RHS is 0. So it is still the solution of the original differential equation. That's not changing.
Okay, sir.
Okay.
So in the final step, we what we did, like after confirming that dm by d, like del m by del y equal to del n by del x, that is after multiplying with integrating factor. After that,
Yes.
what we did?
So first of all, we just confirm that yes, indeed, that after multiplying with the integrating factor, the differential equation is becoming exact, right? So this was just to confirm. All right. Then I am straight away
So it
using
will
this
always
formula.
be exact. It will always be exact, right?
Yes, it was just to double check, just to show you all. That's the idea of an integrating factor, right? Once you multiply with the differential equation, it will become exact. So it is bound to be always exact if your calculations are correct. Okay, you need not do this step always. It's not mandatory. I just wanted to show it to you all that yes, indeed it is becoming exact. So that is why I did this. Okay, this is optional.
Sir, also like in the second integration, if the terms, like all the terms contains like all the terms contains x, or what, then what to do, sir?
You will not take anything, so it will be integration 0 dy.
It will be zero.
Yes.
Okay,
So if
sir.
there are no terms, then it will be 0, right?
Yes, sir.
All right. Any other questions? Anyone? Okay, is this fine with all of you? Any questions? Any other doubts on this? Okay. So if there are no questions, then let me give you one question as homework. Find the integrating factor and solve the differential equation. Okay. So try to work out the integrating factor and then make the differential equation exact and find out the solution for this. Okay. Straightforward question. So first of all, you need to identify if it is falling under any of these four forms and then apply the appropriate formula and then proceed accordingly from there. All right. So I'll request all of you to please give this question a try. It's exactly similar to what we have discussed today. And we'll come back and discuss the solution for this in the next class. All right. So with this being done, we have formally concluded our discussion of the exact differential equations and the first order differential equations as well. All right. So from the next class, I will be discussing some more questions on all the topics that I have discussed on differential equations from the beginning. All right. So if you have any other questions or doubts, you please feel free to let me know, or otherwise we will resolve them during the process of solving more questions as well. All right. So that's it for today's class. All of you, thank you everyone for joining. See you all in the next class. You all can disconnect. Thank you.